Good afternoon. We are going to do the first section of Chapter 4, which is a really important section dealing with congruent triangles. So this first section is mainly vocabulary and notation. So pay particular attention to how things are written, not just what the content is. Okay, so A, definition of congruent polygons are: two polygons are congruent if and only if their vertices can be matched up so that their corresponding parts, corresponding means matching, corresponding parts are congruent. So the vertices have to be matched up 1 to 1, and they must have corresponding parts or matching parts that are the same size. So congruent means same size and same shape. Even if flipped, the figure can still be congruent. Vertices can be matched up in order, and corresponding sides and angles are congruent. You're going to hear corresponding quite a bit in this section. So here's an example. Mark congruent sides and angles in the congruent quadrilaterals. Quad, four, lateral, sided. Congruent, four-sided figures. So we're going to do this by side. So let's start with the sides. Side CD is the shortest. So I'm going to mark that the same as FE. And then the second shortest is AB and HG. Then the third one up, FG and BC. And the last one, AD and EH. You'll notice these figures are mirror reflections of each other, but they are still congruent because it follows the definition. So it's easiest if you do the sides first. I typically use my tick marks to mark which are the small, the medium, and the large sides. It tends to avoid mixing things up. Once you have the sides marked, now you can mark the angles. So I typically start with 1 and go, okay, between 1 and 3, that angle is congruent, between 1 and 3. Between 3 and 2, put a tick mark in it, 3 and 2. Between 2 and 4, double tick marks, 2 and 4. And the last one, between 1 and 4, I'm going to put 3 tick marks. So then you can do the angles. Okay, writing congruency statements for polygons. Okay, number 1, letters must be in the same order for both figures. Okay, so if we were going to write a congruency statement for these two figures, and I'm going to use some colors on these. This is Polygon. Now typically we make the first one in alphabetical order. A, B, C, D is congruent to, there's our congruency symbol, Polygon. And here's where you have to match them up. A, with the double hatches, is paired with H. B, with a single hatch, is paired with G. C with nothing is paired with F. D with 3 is paired with E. So if you were reading this statement, then you would know that first vertices match, second match, third match, and fourth match. So this is the congruency statement for the polygon, and then here's the statement for the matching vertices. So these go in order, so A and H come first, which means angle A is congruent to angle H. B and G come second, so angle B is congruent to angle G. And you get the idea. Third ones go together. Angle C is congruent to angle F, and fourth ones go together. Angle D is congruent to angle E. Now, here's a kind of a tricky part about the directions. If they ask you to write a congruency statement, singular, they just want the first one. If they ask you to write congruency statements, with the S on it, that means you need to do all three of them. So you have to really look close on the directions. Okay, let's do sides. And again, we've marked the sides, so we can go from the drawing or from the statement. Either way, I'm going to go from the statement just to show you how that would work. So A to B is congruent to H to G. AB congruent to HG. Don't forget the bar for sides. So first and second, second and third. BC congruent to second and third, GF. Third and fourth, CD is congruent to third and fourth, FE. And then you go fourth back to first, DA congruent to fourth back to first, EH. So you don't really need to have a diagram to mark congruency. You can do it right off of the statement. All right, flip the page. Roman numeral 2, congruent triangles. Definition of congruent triangles. Two triangles are congruent. Okay, IFF is an abbreviation for if and only if. It's just a shorter way of writing if and only if. Feel free to use it. IFF, if and only if, corresponding parts, which in the case of a triangle is angles and sides, are congruent. If you know that two triangles are congruent, then the definition states that all corresponding parts are congruent. Okay, so this is what's called a biconditional statement. If and only if signals a biconditional statement. And what it means is the phrase that comes first and the phrase that comes second go both ways. You can say if the triangles are congruent, then their parts are congruent, or you can say if corresponding parts are congruent, the triangles are congruent. It goes both ways. That's a biconditional statement. It can be taken either direction. All right, here's another really cool abbreviation you're going to like, Cpctc. It's going to save you a lot of writing. Cpctc stands for corresponding parts of congruent triangles are congruent. Cpctc. Corresponding parts of congruent triangles are congruent. And you can use this as a reason for a proof. Cpctc can only be used for triangles. It's got the T in it, not other polygons. So that example on page 1, which was a quadrilateral, you could not use Cpctc. You would have to say, if the polygons are congruent, then their corresponding parts are congruent. You have to actually say the whole thing versus the abbreviation. But the abbreviation does get used quite a bit. Okay, so here we go. A little bit of practice. Suppose you know that triangle ABC, which is this one, is congruent to triangle HFG. So we're going to fill in the blank based on that. Side AB corresponds to, okay, so short side, short side. Now be careful of the order. A to B is from the acute angle to the right angle. In this triangle, the right angle is on F, so when you list it, it has to be H to F, because the letters have to go in the right order of the vertices. A and H are the same. B and F are the same. Okay, angle C corresponds to, well, we can tell that C and G are the same. So angle G. Is it correct to say triangle CBA is congruent to GFH? So what we have to do is check to see that the three letters are matched up correctly. Okay, so C and G, here's C, here's G, so that's good. B and F. B and F are the 90s, we're good there. A and H are the little acutes, we're good there. So yes, you can say it in that order. Is it correct to say triangle BAC is congruent to triangle HGH. Now your first hint that this is something wrong is that there's two H's in there. So right away you know it's a no. But if that wasn't the case, you'd match up letter by letter. B is a right angle, H is not. So the very first letter we have an issue with. So no, you can't say that. That's not correct. Okay, E, if the length of HG is 5 millimeters, then what can you conclude about triangle ABC? Well, since H to G is this side right here, and H to G corresponds with A to C, that means they're congruent. So if HG is 5 centimeters, H to G, then A to C is also 5 millimeters. That's what you can conclude. All right, exercise number 2. Are the figures congruent? If so, write a congruency statement for the polygons. Okay. So, first thing I want to do is make sure that the angles match up. I have a 60, I have a 50, and I have a single one. So it looks like the angles are matched up. Now we have to look at the sides. Okay, so a single tick mark is in between the 60 and the 50. If I look here, between the 60 and the 50, there are 3, not 1. And they have to be in the right order for it to be congruent. So the answer would be no, they're not congruent. And we would say that side D to F is not congruent to side BC. And that would be your explanation. So you do have to check the order of things quite carefully. All right, flip the page. All right, number 3, are the figures congruent? If so, write a congruency statement. Notice it's singular, statement for the polygons. Okay, so what I usually do is start with one that's really obvious, like this one, the bubble and the bubble, and that would correspond to you, bubble and a bubble. Now remember, these can be flipped. So if I go towards the single tick mark on this one, it's going to go clockwise, and this one goes clockwise as well. So we're going to see if these match up. Bubble and a bubble, single, 3 tick marks, a box, a V, 3 tick marks, 2 on an angle, 2 tick marks on a side, a rainbow on the angle, an opposite V, single tick mark, a circle, and we're back. They all match up. So the answer is yes. And your congruency statement would be polygon, and here we're just going to go in order, G, H, I, J, K, L is congruent to polygon, going in order, U, V, W, X, Y, Z. And there is our congruency statement. All right, last thing we're going to go over is always, sometimes, never questions. And you're going to want to do a little sketch of each of these to figure them out. And there'll be some like this on your homework. Okay, an acute triangle is blank congruent to an obtuse triangle. Okay, so an acute triangle means that all 3 angles are less than 90 degrees. So something like that. An obtuse triangle, the definition is one angle is greater than 90 degrees. So if one angle is greater than 90, and these are all 3 less than 90, those can never be the same. So they are never congruent. All right, number 2, a polygon is blank congruent to itself. Okay, well, if I have a rectangle and I draw itself again, they're always going to match because they are the same. That would be an always. A polygon is always congruent to itself. There's a property for that. It's called reflexive property. A shape is always congruent to itself. Okay, number 3, a right triangle is blank congruent to another right triangle. Okay, so I can draw a right triangle. I can draw another right triangle that it matches, but I can also draw a right triangle that it doesn't match. So this would be sometimes. See how sketching it out really solidifies your thinking? In a sometimes scenario, you should be able to draw both a yes and a no. Okay, number 4, if triangle ABC is congruent to triangle XYZ, angle A is blank congruent to angle Y. Okay, so first of all, A and X are in corresponding positions. So A and X are always going to be congruent. A and Y are not in the first position, but is it possible that A and Y could be the same? Well, if A and B are the same, then X and Y would be the same. And that would be something like an isosceles triangle with two congruent angles. That's A and that's B. And this one's X and that's Y. You can see that A would be congruent to Y. So it is possible. This is a sometimes. Sometimes in the case of isosceles. Number 5, if triangle ABC is congruent to triangle XYZ, angle B is blank congruent to Y. Well, B and Y actually have matching positions, so it will always be congruent because that's how congruency statements work. Last one, number 6, triangle ABC congruent to triangle XYZ, side AB, okay, it's these two, is blank congruent to YZ. Now, on first blush, AB and YZ are not in corresponding positions. But if BC and, so if we want AB to be congruent to YZ, then we would have to have those sides being congruent. So let's see, if I draw a triangle, ABC, so if AB and BC are the same, then when I draw the matching triangle, XYZ, XY and YZ would be the same. So in this case, AB would be congruent to YZ because they have two congruent sides. So it's possible. So this would be a sometimes congruent. Sometimes it would be congruent, but it's not evident in the statement that is for sure congruent. All right, I hope the exercises help you on your homework. Have a great afternoon.